Greetings everyone and welcome back to the bench. Just show you my little impromptu wire tracer circuit here I'm using. In my fixer-upper house here, there's a bunch of dead circuits. There's some wires up in the attic that are just open. No voltage on them. I want to trace them, see where they go. Have some circuits running out to the detached garage / barn, and they don't go anywhere. So I want to make a quick little circuit here I can use. I'm not going to go out and buy anything, so I'll just make something real quick so I can see if I can trace those wires down. Okay, so for the signal source, you can make something that has like a warble tone, or a gated pulse tone or something like that. But I'm just going to use music. I'm just going to send signal into an amplifier and boost up the voltage. Then connect it to the wire under test or trace, and I use this Radio Shack little speaker amp as a receiver. And it's just got a little probe plugged in, just a single wire sticking out, insulation on it. It doesn't have to be bare. And you can probably even use like an LM386 in its high gain mode with a probe like that if you wanted to make something. So here's the transmitter circuit. You have your signal source, whatever that might be. In my case, like I said, amplifier. It goes through a 10 ohm resistor into a step-up transformer. The resistor is there for, to protect the amplifier from any inductive feedback, or, if something shorts over here, you're not going to overload the amp. And since this is really used open circuit, it doesn't hurt it any having that resistor there, so that's the reason for that. Now for the transformer, I'm just using a output transformer from an old tube radio set. You can use even a small power transformer as long as the secondary is a lower voltage, like say 6 volts or less, and the secondary is boosted up. That way it makes it easier for this to pick up the signal. So let me give you a little demonstration of this in operation. Okay, I'm playing music here into the amplifier, and this is directly connected to the output. It's not going through any transformers or anything. And you can hear it's picking it up. It's rather weak. So that's the reason for using the transformer. Even though it can pick it up, you might have to pick it up through a short distance. So having a higher voltage will allow the receiver to pick it up better. So let me hook it up to the transformer. Okay, I've hooked it up to the transformer, put a little neon light there, and at loud parts of the music, it's enough voltage to ionize the gas there and make it light up. The amplifier might be clipping, or that distortion's from the neon energizing. But yeah, it's a lot louder. So I can pick up the signal through a short distance. Might help locate the wire. So yeah, if you build one of these circuits, do so at your own risk. You want to use your due diligence to make sure that there's no power on the wire under test, and that wire is not grounded, because you'll just ground out the signal you're trying to receive. I decided to make a test tone. I used Audacity to create a square wave of 1K and 700, so it alternates back and forth between those. And I decided to use that because it's a little easier to hear, and being a square wave, it'll be harmonically laden, and that also helps with making it easy to hear. And of course, I won't have to deal with copyright. Of course, you can use microcontrollers, digital logic gates, or even discrete components to create a similar method to make a tone. But just to keep it simple here, I'm just going to use my music player, do it that way. Okay, let's test this thing out. Okay, I'm up in the attic. If I sound a little muffled, I have a mask on. I don't want to breathe the crap up here. But I have this wire I tested several ways to be open and dead, so it's safe to connect to. I get sound out of all the conductors because it's open and not grounded, just floating. So the signal capacitively couples to the other conductors. So I just have to follow this cable. Well, that wasn't much. It just goes over here about 4 feet and pops back out. So it's just a cut off section of wire. You can also detect some AC. Though you have to be careful with that because AC can capacitively couple as well. And, you know, that could be an open line just getting, you know, capacitively coupled signal. Alright, don't try this at home. This is a live switch, but if I keep it off, the load side is open. So yeah, I have to be careful there. Strong signal. I did have to ground it because, you know, with such a long run of wiring, it tends to weaken the signal. See how the ground kind of shields it? You almost can't hear it anymore. It's very strong there. So let's go see where this wire leads to. Picking something off this doorbell, but it's along with AC noise, so I think it's just capacitively coupled to wires. See how sensitive this is. Picking a little bit up in the metal door frame. I think I found where this leads. This is on the side of the garage here, which is a separate building from the house. And I'm picking up a clean signal. So yeah, I think that's the abandoned wiring. That's some wiring coming out here. There's like 3 circuits. And one's a mystery, one's connected, and one must go to that switch. Okay, I'm on the other side of the wall inside the garage where those circuits came in, and yeah, nothing. So when I was redoing the siding on this garage, I had that circuit that was dead, so I just capped it off inside that little box there and just abandoned it. So yeah, that's where that goes, to that light switch. So yeah, I can use that thing to find out what that other abandoned circuit is in that little junction box there. But here's the side of my garage. I put new siding on it. It looks like a new building. Got a new roof put on it and the house as well. All painted up. Looks really nice. And here's what it looked like before I sided the other side. So it's kind of rotting out. The sill beam is all rotted out. Had to replace all of that. There's 3 more sides to go. Yeah, you have to watch the strength of the signal. I'm in the far corner of the house, and it couples into the downspout. I mean, this is further away from the source as you can get on the house, and it still couples in, so yeah, you have to watch that. So there you go, a quick thrown together circuit already paid in spades to trace wires. Might make it more permanent. I can generate that same tone using probably a hex inverter chip and add some safety, maybe a capacitor on the output to block AC line frequency just in case it's accidentally hooked up, but not block the signal going out when it's properly connected. And I also can check the transient abilities.
Your cartridge probably has good transient ability.
Ooh, transient ability. Well, there you have it. Thanks for watching.